All, are you ready?
Yes, sir.
Okay. So today I'm going to discuss the programming part of 8085. There are a lot of programs which can be made to solve different kind of the problem, of course, using assembly language programming, which is meant for 8085. So to start with the programming, first of all, going to discuss about the data transfer instructions and then their applications. So one of the primary operation of 8085 is to copy the data from one place to another place, and for that we use different instructions. We all are familiar with such kind of instructions: move RDRS, which is going to copy the data from the source register to the destination register. Similarly, move MVI RD 8-bit, whenever we have to copy the 8-bit data to the destination register, which has to be defined within the instruction, we use MVI. And in is a kind of instruction by which we will be reading the data from the input device. Of course, it is designated by 8-bit address. Out is a kind of an operation in which the microprocessor will be displaying the data to the output device, which output device whose 8-bit address has been defined within the instruction. So as far as the first instruction is concerned, this is single byte MVI RD 8-bit. It is 2 byte in 8-bit address, 2 byte out 8-bit address. This is again a 2 byte instruction. And the purpose of all these instructions is to copy the data from the one place to another place. One thing to be noted very specifically, which is very important, that in case of 8085 microprocessor, data transfer operation is not going to affect any kind of flag. Second, it is going to change the content of the destination register. It is going to change the content of the destination, but it is not going to change the content of the source. The content of the source will remain as it is, but the content of the destination will be changed. Means whatever is this previous value, it will be abolished and the new value will be placed at that place. So let us have an example of that. Suppose we have a problem saying that load accumulator by 79H and move it to the B register. So what will be the program for that? So I'm writing program for that. First of all, we have to load the accumulator by by 79. So what we'll do, we will write an instruction MVI accumulator A 79H. So what this instruction will do, it will copy 79H into the accumulator. And then it says that move it to the P register. So for that, what we'll do, move B A. So, and then alt. So this is simple 2-line program for loading the accumulator by 79. Of course, in the comments you will write load 79H in accumulator and then copy content of accumulator in B register and then end. So this is how the program is being written for this particular problem. Now, whenever we have to work with input and output device, whenever we have to read, this is the operation which you are going to do, transferring the data within the register. Now, these two instructions in 56H, what does it mean? In 56H instruction, what it will be doing? Copy 8-bit data from input device whose port address is 56. Now here, this इन के साथ जो 56 लिखा हुआ है ये डेटा नहीं है, ये पोर्ट एड्रेस है इनपुट डिवाइस का. उसी तरीके से out 65 is the port address of what? Of the output device in which the data from the accumulator will be loaded. So 8-bit data from the input device whose port address कहाँ ये कॉपी करेगा, और जितने भी इनपुट आउटपुट ऑपरेशन होते हैं वो सब एक्यूमुलेटर के रेफरेंस में होते हैं. माने इनपुट डिवाइस से जब भी डेटा आएगा तो वो एक्यूमुलेटर में आएगा, और आउटपुट डिवाइस में जब भी आपको डेटा भेजना होगा तो आप एक्यूमुलेटर के ही डेटा को आउटपुट डिवाइस पे भेज सकते हैं. सो दिस इज हाउ इट वर्क्स. Now, the most important aspects of the data transfer operation or the programming is the addressing mode. Addressing modes can be defined as the different way by which we are going to specify the operand. There are different way by which the operand can be specified. You might have seen. If you know the data, you will be writing the data within the instruction. If you don't know the data, you know that the data is residing in a register, then you write the name of that register. If you know the memory location where the data is residing, so what you will be doing, you will be assigning the address of that memory. So there are many ways by which the operands are being specified. So the different ways, different formats of specifying the operand is known as addressing mode. So this is very important. Addressing mode is very important, and you have to be very, very careful about that, and you have to know the different addressing modes. In 8085, we have 4 addressing mode. The first addressing mode is known as immediate addressing mode. Immediate addressing mode is a kind of a mode in which the data has to be supplied immediately within the instruction. And this mode will be used whenever we know actual data. If we know the actual data, then we will be using immediate addressing mode. And the example of immediate addressing mode is MVIR data, 8-bit data. Second mode is known as register addressing mode. Register addressing mode is a kind of a mode in which we signify the register, name of the register in which the data is residing. Immediate addressing we use when we know that what is the actual data which has to be moved. But register addressing mode तब इस्तेमाल किया जाता है जब हमको ये मालूम हो कि डेटा हमारा इस रजिस्टर में है. So example of register addressing mode is move RDRS. So move RDRS is an example of a register addressing mode. क्योंकि इसमें हमको डेटा नहीं मालूम है, हमको खाली मालूम है कि डेटा कहाँ पे है, source register में. Then the third addressing mode is known as direct addressing. Direct addressing mode is a kind of a mode in which the address of the data is defined within the instruction. Now, don't be confused with immediate addressing and the direct addressing. Immediate addressing is used whenever we know the data. But direct addressing is used when we know that at that particular address of the memory, the data is residing. So in that case, we have to define directly the data. हमको ये एड्रेस डिफाइन करना पड़ेगा जिस भी इंस्ट्रक्शन में कि डेटा का एड्रेस क्या है. So that is known as direct addressing. And the last one is the indirect addressing. We don't know the data. We also don't know where is the address. And even though we are using an instruction, move RM, what does this instruction do? This instruction will do it copy the data from the memory. Now the address of that memory is not defined within the instruction. We know that this instruction is going to copy the address, copy the data of the memory. Which memory? Whose address is defined in the HL pair. So it means we are indirectly addressing by using this instruction. So this instruction is an example of indirect addressing. So these are the 4 certain ways in which the operands are being defined, and these different ways of defining the operand is known as addressing mode. Immediate addressing, register addressing, direct addressing, and indirect addressing. There, it is sure that the questions in the university paper will be asked on the addressing mode, either in format of 2 marks or in the format of 5 marks, along with the example. And you have to also show that why it is an immediate addressing mode. Why this example it belongs to immediate addressing, like that. Any question? No question.
No, sir.
Now, as I told you that before we do programming, the first and the foremost process is to analyze the problem, then develop a step-by-step procedure, and then show that step-by-step procedure through a pictorial representation that is known as flowchart. So flowchart is an art to assist and clarify the thinking process and communicate the programmer's logic or the thoughts to the others for the solution of the problem. हम किसी भी प्रॉब्लम को किस तरीके से सॉल्व करेंगे, जो हमारी थॉट्स है, जो हमारा थिंकिंग प्रोसेस है, उसको पिक्चोरियल रिप्रेजेंटेशन फॉर्म में शो करना is known as flowcharting. And the second important point is it is independent and remain common irrespective of the programming language. कोई भी programming language हम इस्तेमाल करें, it is independent of the programming language and it remains common, meaning thereby algorithm as well as the flowchart remain as it is same for solution of the problem. Only the difference lies in the coding process. If we are using assembly language, we will be using mnemonics code. If we are using high-level language, we will be using the code of those language by which we are trying to solve the problem. And for drawing the flowchart, different symbols are being used. This is a simple flowchart, an example of a flowchart. in which we have certain representation of the boxes: start, enter the number in the register, output the number, and stop. So the different flowchart symbols which are being used, the arrows are being used to indicate the direction of the program execution. If the direction is this one, it means from the start it will move to this place. Rectangle represents the process or the operation. Diamond represents a decision-making block. Oval shape indicates the beginning of the end of the program. Double-sided rectangle represents the sub-program or the subroutine. And this circle with an arrow represents the continuation of the process. If you have to connect one flowchart with the another flowchart, you will be using the connector. So this circle will be used as a connector. So these are the certain flowcharting symbols. Then how we write the assembly language program. So the assembly language program, the format of writing the assembly language program is, first of all, the memory address in the hex format, machine code in the hex format, instruction separately in the form of opcode and operand, and then comments. Comments is a kind of a column in which you have to write what this instruction is going to do. So this is the format which you have to follow. Of course, there will be change in the format later on whenever we will be doing some programming. Then there is a possibility that there is certain change, but the format remains as it is: memory address, machine code, opcode, operand, and the comments. So in this way, so what is the memory address? Memory address is defined by 16-bit binary numbers, which can be converted into 4-bit hexadecimal, 4 hexadecimal codes. Similarly, machine code is represented also in the form of a hexadecimal code. Opcode is an operation code, which is the operation which the instruction is going to perform, and operand is a kind of a material on which the operation has to be performed, and comments that what the operation is going to do. Now, how to enter and execute the program? The first and the foremost process that we start with the reset key. First of all, we reset, and then we enter the 16-bit starting address of the program in which we will be writing the first machine code of your program. And then enter and store all the machine codes sequentially. Remember that all the codes are in hexadecimal number, as well as all the memory address will also be in hexadecimal number. And once we become sure that all the machine code has been entered in the hexadecimal number, then we again reset the system and enter the memory address where the program begins, and then we try to push the execute key. And whenever we are pushing the execute key, a symbol will be displayed on the LED screen, E, which shows that your program has been correctly executed. And once it is executed, you can check the result wherever it is as per the program. Now, let us go with an example how it can work. Suppose we have two numbers. Let us go with an example. Suppose we have two numbers. The last example which has been suppose we start writing the program from 8,000. So what we'll do, we will not write first the memory address. First of all, what we will write the instructions first. So we'll write MVI, then operand. Operand is A79H. And in the comment, we will write copy 79H in accumulator. Copy 79H in accumulator. So whatever we will do, we will write the, sorry, now there is no need to write H in because it is already written. Suppose this is so. Now, since this instruction is a 2-byte instruction, so it will take two memory location, 8000 and 8001. So what we will do, the next instruction will be written at 8002. It is move B A copy accumulator in B register.
Sir,
Anji,
sir, can we directly move the
eh? Hello. Anji, बोलिए.
sir, can we directly
हाँ. Can we directly? Yes.
to register?
आपकी आवाज नहीं आ रही है. हाँ जी, पूछिए. हाँ जी, पूछिए.
Sir, yes, sir. Can we directly move the 79H data to the register B using MVI?
Why not? Why not? बिल्कुल कर सकते
Why
हैं.
are we loading into accumulator
Because the
first, then we are
problem is saying that first load the 79 in accumulator and then copy the data into the B register.
Okay, thank you, sir.
So once we write the instruction, and this instruction is a 2-byte instruction, so it will take two memory location. First memory location will be the hex code of MVI A, that is 3E. Second byte is 79, so here I am writing 79. And so this instruction will take two memory locations. So after 8001, then I have written move BA. The code of move BA, this is 1-byte instruction. The code of move BA is 4F, so we'll write 4F. And then since it is a 1-byte, so it will take only one memory location. Then 8003 will be halt. So halt is having the code 76. So in this way, we used to write the program. First of all, we write the instructions along with the comment, and then only we write the memory address and the machine code. Keeping the thing in the mind that the instructions which are being written by you for solving your problem, you have to be very careful that from the beginning, you have to be careful that whether the instruction is a single byte instruction, is a 2-byte instruction, or is a 3-byte instruction. And accordingly, you will allot the memory location for storing that number. If, by the way, here instead of 79, if you forgot to feed 79 and directly you write here 4F, suppose you forgot, and here you write 4F. Suppose. Then what will happen? Here we write 76. Then what will happen? Here you have to feed, after MVIA code, you have to feed 79, but you have not feeded that one. What you have feeded? 4F. So what will happen? The program will be executed, no problem. But instead of taking the 79 data, it will take 4F as a data. So that is why it is necessary that you have to keep in your mind that the instructions which are being written, it belongs to how many bytes, and according to that, the memory address should be defined. So here, instead of that, you will write 79H. No. Here we will write 4F. And then you will write 8003. Hmm. 8003 alt 76 हो गया है. This is the correct program. You got my point? Okay. Now next one is the arithmetic instruction. Arithmetic instructions are very important instructions, and there are certain important aspects of arithmetic instructions. Please listen carefully. Of course, arithmetic instructions are used for addition process, subtraction process, increment and decrement. 4 operations in the arithmetic instructions are being done. The important aspects of arithmetic instructions are except INR and DCR instruction. INR and DCR instructions are those instructions which is used for increment or decrement. इन दोनों इंस्ट्रक्शन को छोड़ करके बाकी इंस्ट्रक्शंस कैसे काम करते हैं, दैट इज रिटन. सबसे पहला पॉइंट है assumes implicitly that accumulator as one of the operand. अरिथमेटिक और इंस्ट्रक्शन जब भी एग्जीक्यूट होता है तो ये ऑटोमेटिकली डिफॉल्ट है. अरिथमेटिक इंस्ट्रक्शन को एग्जीक्यूट कराने के लिए कम से कम 2 नंबर्स चाहिए, चाहे वो एडिशन हो चाहे वो सब्सट्रैक्शन हो. उसमें से एक नंबर जो है वो हमेशा एक्यूमुलेटर में होगा, यानी रेफरेंस पॉइंट इज ऑलवेज एक्यूमुलेटर. इट इम्प्लिसिटली ऑटोमेटिकली डिफॉल्ट assumes that accumulator is one of the operator or one of the operand. The second point is it modifies all the flags according to the data condition of the result. जब भी कोई भी अरिथमेटिक इंस्ट्रक्शन एग्जीक्यूट होगा एक्सेप्ट INR एंड DCR, तो जितने भी फ्लैग हैं वो सब अफेक्टेड होंगे रिजल्ट के कारण. तीसरा, इट विल प्लेस द रिजल्ट इन द एक्यूमुलेटर. रिजल्ट हमेशा एक्यूमुलेटर में ही प्लेस होगा. चौथा, डू नॉट अफेक्ट द कंटेंट ऑफ द सोर्स. सोर्स का कंटेंट कभी चेंज नहीं होगा, हमेशा डेस्टिनेशन का, और डेस्टिनेशन इसमें हमेशा एक्यूमुलेटर होता है, इसलिए एक्यूमुलेटर का कंटेंट चेंज होगा. ये 4 इंपॉर्टेंट पॉइंट्स हैं. पहला कि एक्यूमुलेटर वन ऑफ द ऑपरेंड होगा. दूसरा, सारे फ्लैग मॉडिफाई होंगे. तीसरा, रिजल्ट स्टोर होगा एक्यूमुलेटर में. चौथा, इट विल नॉट अफेक्ट द सोर्स रजिस्टर. सोर्स रजिस्टर में जो कंटेंट है वो एज इट इज रहेगा. सपोज करिए आपने कहा ऐड बी, सो व्हाट इट विल डू, इट विल ऐड द कंटेंट ऑफ बी विद द कंटेंट ऑफ एक्यूमुलेटर एंड स्टोर द रिजल्ट इन द एक्यूमुलेटर. सो मीनिंग thereby the content of B register will not be changed. Just hold on.